Now, when we're implementing bootstrapping for estimated coefficients from regressions, we have a package called boot in R, and it's really nice and simple to integrate that in with the regressions that we're already estimating. So here you can see I'm loading the library called boot. Now, I'm just making this temporary function. Again, essentially all this is doing is running whatever our formula is and getting or storing the coefficients from that estimated regression, right? And all I'm doing here is creating a random sample. So the first thing is you create a random sample, right? In this case, it's going to be of size, oh, I don't know, 100, I think maybe. I don't know exactly what the sampling size here is, but let's say it's 100, right? So we take 100 observations, we run a regression from that data set, we return those coefficients and store that, and we're going to do that 100 or 1,000 different times, right? And here we're doing that we're doing it 1,000 times here, so 1,000 rounds of bootstrapping. And the regression that we're interested in running, you'll maybe remember this from previous classes, where we're interested in estimating the prestige of a occupation based on the income level and the education of an individual. So what's really nice about this package is that we can look at what we would get, our estimates, if they were using a normal parametric model with our normal assumptions, right? So we're still going to calculate our t-statistic. We're still going to find out whether or not that estimated coefficient is statistically reliable based on the p-value that we would have gotten from the normal test statistic that we would have run. But we're also going to get back our answers from the bootstrap samples. And what's interesting here is that it tells us what the original was, but it also tells us what the bias is. And so this is cool because we can essentially see, should we be bootstrapping, and how does the do the results differ when we bootstrap versus the original? And if we look, the results seem pretty reasonable, but you can also set up confidence intervals for those bootstraps and investigate them. So here what I'm doing is I am essentially getting the lower bound as well as the upper bound. And here we can see that, in fact, when we look at the the intercept here, our intercept is not distinguishable from 0, but we do find that the effects for our second and third beta are distinguishable from 0. And that's important because in the original model, under the normal assumptions that we had, right, when we had our normal test statistic, both of those variables were not distinguishable from 0.